Okay, section 3, we can do linear systems with constant coefficients. So we learned last time what a first order linear system looks like, and it's the derivative of x1 with respect to t is some function of t times xt, and all of these, right? And the first order linear system is where you could write each of them as derivatives of each of the x2's, right? And they're in terms of all the other ones, where each of these aij of t, so each of these guys are functions of t, and so is the b. These b guys are also special functions on this interval, and it's called a first order linear system. The aij's are the coefficient functions of the system. And then also, if all of these b's are all 0, well, then we've got a system that's homogeneous. Otherwise, if there's something other than zeros here, some other function, then it's not homogeneous. So now what we're going to concentrate on today is solving linear systems that have constant coefficients. So all of these aij's are going to be constants. They're not going to be some function of t. So all of these guys will be constants on each of these, right? But it's still the first derivative of x1 is, defined in terms of these. Now your b's will still, they might be 0. They might be homogeneous, or they might have some other function. But all of these guys will all be constant coefficients. So all of the aij's are constant. So those are the type we're going to do today. Methods of solving, we're going to use substitution, elimination. You could use Cramer's rule. I'm not doing that today, but those are ways to solve them. If you're using the elimination method, some valid operations on systems of equations is you can interchange equations. You can multiply an equation by a constant as long as it's not 0, and then you've got a new equation of just multiplying that c times your equation, right? Or you can also apply P of G. You can apply a polynomial operator to one equation, and then add it to another equation. And so then you've got some new equation. Help if I slid this up, right? So you can apply the polynomial operator on to one of the equations, add it to the other, and then that gives you a new equation. We're going to do 3 examples. They're doozies. They take a while, so I expect this video to not be a short one. I'm hoping I can make it short, but fair warning. Okay, so let's do example 1. All right, so first example is we've got d of x1 is equal to negative 2x1 plus x2, and d of x2 is negative 3x1 plus 2x2 plus 2 sine of t. And so these are definitely, it's a first order linear system, definitely constant coefficients, because on each of the x1s and x2s, they're just constants, they're not functions. So what I'm going to do is I'm going to rewrite these a little bit so that they look more like what we've seen with these systems. And that is that if I bring, for the first equation, I'm going to rewrite it to where everything's on the same side. And so I would have a dx1 plus 2x1. So I'm going to rewrite it as d plus 2 of x1. I would have subtracted the x2, and now it's equal to 0. So there's my one equation just rewritten. I'm going to do the same thing with this one, where I'm going to add the 3x1 over. I'm going to subtract the 2x2, but I also have a dx2, so that means it's a plus d minus 2 of x2, and then I'm going to still leave the function of t on the right-hand side. Okay, so we're going to do elimination. What I notice is on x2, there's a minus sign here and a plus sign there. So what I'm going to do is take this first equation, and I'm going to apply d minus 2 onto it. I'm going to operate on this first equation by d minus 2, and then I'm going to add it to the second equation so that I would have, oh, here, I'll rewrite it. So I'm going to go, it'll be a d minus 2, times d plus 2 operating on x1. I'm going to have a minus d minus 2 operating on x2. And then d minus 2 times 0 is still 0. And then this is still a 3x, second equation I just copied down, plus d minus 2 operating on x2 is equal to 2 sine of t. I'm going to add these two guys together. Now, so then that means that my new equation is going to be a, well, if we multiply those guys together, that's a d squared, minus 4 and then a plus 3 operating on x1. These two guys will cancel. And then we've got an equals 2 sine of t, 0 plus 2 sine of t. So this is my new second equation. So now what I've got is, my first equation was d plus 2 operating on x1 minus x2 equals 0. And then this guy is my new second equation, which is a d squared plus 4 and or minus 4 and plus 3 gives you a minus 1 operating on x1 equals 2 sine of t. All right, so let's work on this second equation here. Find the solutions for it. Now, our associated homogeneous for this second equation here would have been that d plus 1 times d minus 1 on x1 equals 0. So your r is plus and minus 1, which means that your homogeneous for x1 here would be c1 e to the 1 times t plus c2 e to the negative 1 times t. So there's your homogeneous. We now need to find the annihilator of 2 sine of t. So the annihilator of 2 sine of t is d squared plus 1, because if you take the second derivative of this guy would be negative 2 sine of t. So d squared plus 1. Well, that means that your r would be plus or minus I. And that's an a is 0 and a b is 1. So that means that your particular for x1's particular would be c1 e to the 0 cosine of 1 times t, and then plus c2 e to the 0 sine of 1 times t. And then if you remember, we're going to need to take the derivatives of this and stuff. So I'm going to rewrite this. E to the 0 is just 1. The c1 and c2 I'm going to replace with a's and b's. So this is an a times cosine of t plus a b times sine of t. So that's x1 particular. Now, in order to solve for this, I need the first derivative and the second derivative, because I'm going to be plugging them into this equation here to be able to solve for it. So I've got x1 particular. So the derivative, first derivative of a cosine of t would be negative a sine of t. Derivative of b sine of t would be b times cosine of t. And then the second derivative would be derivative of sine is cosine, so a negative a cosine of t. Derivative of cosine is negative sine, so a negative b sine of t. So we're going to take these guys together, and I'm going to plug it into d squared minus 1 operating on x1 equals 2 sine of t. So that way we can solve for these constants. All right, so that means second derivative of x1, which is this guy here. So a negative a cosine of t minus b sine of t. And then a minus x1, so a minus, and then x1 was a cosine of t plus b sine of t. and then all of that's equal to 2 sine of t. Show you. This one is the d squared of x1, which is this guy. And then this guy is just that x1. So this was minus 1. So just a minus 1 x1. No? Okay. All right. We want to equate coefficients. So I've got cosines and sines in here. I'll collect the cosines together. Cosine, I would have a negative a, and then another negative a. And that's it. And then sine would be a negative b, and then another minus b. And so, you know, I don't have a cosine on this right-hand side, which means that this guy must equal 0. And then here, I've got a 2 sine of t, so the coefficient on sine must be 2. And so you've got that coming from here, negative 2a must equal 0, which means a must equal 0. And then here, negative 2b must equal 2, since the coefficient on sine is 2. So that means b is equal to negative 1. And so we now have the particular solution for x1 is, scooted it up too far. It was a times cosine of t, but a is 0, so bye-bye. And then negative 1 times sine of t. So negative sine of t is your particular. So putting together, if you remember, it's been a little while, I had a week off. If you remember, your x1 will be the homogeneous solution plus the particular solution. So we've got x1 is going to equal, your homogeneous solution was c1 e times e to the t plus c2 times e to the negative t, and then plus your particular, which was a negative. So instead of writing plus a negative, I'll just write minus sine of t. And this part came from x1 homogeneous, and then this part is x1 particular. Okay, so we've got x1, nice. Yeah. Well, so far, this example actually gave us initial conditions also, so we're going to actually be able to solve for C1 and C2 in a few. All right, so now we want to solve for x2 as well, and from the first equation was, what did we have? We had, the first equation was d plus 2 operating on x1 minus x2 equals 0. So that's the first equation, right? Well, if I just isolate x2, adding it over, that means x2 is going to be d plus 2 operating on x1. All right, so what was the first derivative of x1? All right, we got it right here. Here's x1. I'm going to take the derivative. What's the derivative of c1 e to the t? Well, it's c1 e to the t. Derivative on c2 e to the negative t, that's a negative c2 e to the negative t. And then the derivative on sine is cosine, but you're subtracting it, so it's a minus cosine of t. So that's the first derivative of x1. And then you've got a plus 2 times x1. So plus 2 times, and x1 was c1 e to the t plus, just scooch over because I'm going to run out of room, plus c2 e to the, no, I'm not going to do that, plus c2 e to the negative t. I ran out of room, sorry. And then a minus sine of t. You know? We can combine like terms and stuff so that we've got x2 would be a c1 e to the t plus 2 c1 e to the t. So that will give you a 3 c1 e to the t. You've got a negative 1c2 plus a 2c2, so that's a plus c2 e to the negative t, and then we have a minus cosine of t, and then a minus 2 times sine of t. Okay, so now we've got x1 and we've got x2, but we were given some initial conditions so we can actually solve for the c1s and c2s and stuff. So your initial condition given to you on the notes were that x1 at 0 is 3 and x2 at 0 is 4. So let's start by plugging in that x1 at 0 is 3. All right, well, that would give you a 3 is equal to c1 e to the 0 plus c2 e to the 0 minus sine of 0, which that just means that you've got 3 is equal to c1 plus c2. Okay, now we'll do the same thing, but with x2. So the initial condition for x2 was that x2 at 0 was 4. And so we've got a 4 is equal to 3c1 e to the 0 plus c2 e to the 0 minus cosine of 0 minus 2 times sine of 0. So that'll give you a 4 is equal to 3c1 plus c2 minus 1, and then a minus 0. Yeah, and so I can add this 1 over and make it, okay, 5 is equal to 3c1 plus c2. Okay. How about, so I'm trying to solve for c1 and c2 right now, right? And I've got this equation and this guy. And I notice that if I just multiply this by a negative 1, right, and bring it down here and then add them together, that would give me a negative 3 equals negative c1 minus c2. Yeah. And adding those together, you would get a 2 equals 2c1 plus 0. So your 1, c1 is equal to just 1. Plugging that back in to the fact that 3 is equal to c1 plus c2, plugging it into this guy. You also could have plugged it into this one, doesn't matter, but this one seems easier. 3 is equal to 1 plus c2, and so c2 is 2. Yay! So we solved for the c1s, we got these guys, and so we'll just plug them in. So that means our final answer is x1 was equal to c1 times e to the t. Well, c1 is just a 1, so it's an e to the t, plus c2 e to the negative t, so plus 2 e to the negative t, and then minus sine of t. And x2 was 3 times, slide it back down, x2 was 3 times c1, well, c1 is just 1, so that's just a 3e to the t, plus c2 e to the negative t, because c2 is 2, and then a minus cosine and a minus, oh, and I'm off the page, I apologize, and then it was a minus cosine and a minus 2 times sine of t. There you go, solved that system. If you were to actually go and plug it in, like take the first derivative of this guy, take the first derivative of this guy, and it'll end up equaling, it's got to satisfy both of those equations, right? Because that's what it means to be a system. Okay. All right, so let's do another example. Example 2 they did not give us any initial conditions for example 2 or example 3. So for this example, we're going to leave our answer in terms of C1s and C2s. We're not going to have to solve for them. All right, so 2e to the negative 2t and ax1 minus d plus 2x2 is equal to 0. Okay, so not too bad, right? They obviously, like, it's a d plus 2 and then a minus a d plus 2 on the x2. So let's add these guys together. And I'll replace with, well, I'll replace it. It'll become my new equation 1. That's what will happen. So if I add these two guys together, you would have a d squared plus d operating on x1. These two guys cancel, and then this plus this would give you a 2e to the negative 2t. Second equation I'm still going to keep. So this is my new first equation. And then the second equation is a d of x operating on x1 minus d plus 2 on x2 equals 0. So let's work on the first equation first. So that first equation is a d squared plus d operating on x1. Well, that's a d times d plus 1 operating on x1. Yeah, and we know how to solve these. You got to start off by finding the associated homogeneous. Yes. So associated homogeneous would be you would have an r equals 0 and an r equals negative 1, or these two guys. And so your homogeneous for x1, since that's the one that's there, right, would be c1 e to the 0t plus c2 times e to the negative t, which means, I'll just clean it up, e to the 0 is just 1. So this is just a c1 plus c2 times e to the negative t. So there's the homogeneous. We then need to find the annihilator. The annihilator of 2e to the negative 2t is just a d plus 2, which that means that your r would be negative 2. And so the particular solution would just be c1e to the negative 2t. And then remember what we would do. I need to plug that into this guy, so I need the second derivative of it. So I'm going to do x1 would just be a times e to the negative 2t. x1, particular first derivative of it, would be negative 2a times e to the negative 2t. And then the second derivative would be a positive 4a e to the negative 2t. So we're going to take these, and I'm plugging it into the whole, it was a d squared plus d operating on x1 equals 2e to the negative 2t. Now, so second derivative is the 4a e to the negative 2t. First derivative, there's a minus sign, so it's a minus 2a e to the negative 2t. Oh, look at how nice that is. Those guys are the same. You end up with, this is just 2a is equal to 2, equating coefficients, right? Because this guy ends up just being a 2a times e to the negative 2t. Your coefficient is 2a on the left. Your coefficient on the right is 2. And so in that case, your a must equal 1. So your particular solution is just 1 times e to the negative 2t. And so x1 is, you got to do the homogeneous, which was c1 plus c2 e to the negative t, and then plus the particular. There's x1. Now, we got to solve for x2. I'm going to do that by substituting it into the second equation. All right, so substituting it into the second equation. If you remember, the second equation was d x1 minus d plus 2 operating on x2 equals 0. Now, all right, so first derivative of x1, I got to take the derivative of this guy. So let's do that. How about, so what would x1 prime be? It would be a 0 minus c2 e to the negative t minus 2 e to the negative 2t. Now, so that's why I'm going to replace dx1, right? To say dx1 means x1 prime. All right, so we've got negative c2 e to the negative t minus 2e to the negative 2t. And then we're going to subtract from it the d plus 2 operating on x2, which is what we're trying to find right now. We're trying to find x2. So let's add this d plus 2x2 over here to the right-hand side. But of course, I'm going to write it on the left because that's what I do. So what I have now is d plus 2 operating on x2 is equal to negative c2 e to the negative 2t minus 2e to the negative 2t. All right, and we can solve this. We know how to solve this, and that is, we're going to find the associated homogeneous first. And that would just be d plus 2 operating on x2 is equal to 0. So that's an r equals negative 2. Yeah. So that means the homogeneous solution of x2 is just I'm going to use a different letter here. I can't use the C2s and C1s or whatever because they were already used, and this is some other constant. So I'm going to say C3. So it's C3 times e to the negative 2t is going to be your associated homogeneous. Okay, do you remember that rule? We need to find the annihilator of the right-hand side. But remember, there was a theorem that said you can find the annihilator of this guy and the annihilator of that guy and combine them together. Yeah. So I'm going to do them separately. The annihilator of, negative c2 e to the negative t is just d plus 1, which that just means that it's going to be a times e to the negative t. And the annihilator of negative 2e to the negative 2t is d plus 2. Uh-oh. D plus 2. D plus 2. Do you see that it's got a repeated root from the particular and the homogeneous? Yeah. So that means that this composition of P of D on Q of D is actually a D plus 2 and another D plus 2 and a D plus 1, which means you've got repeats. So that means X2, I'm going to put a little star saying, remember, it's the homogeneous, right? Well, not even that. Let's go to here. D plus 2 and D plus 2 means that you would have, I'm going to bring in another letter. Sorry, got to, because I don't want you to think that I'm talking about the same C3s or whatever. This guy would be some constant times e to the negative 2t. How do you remember how you handled multiplicities? This is a multiplicity of 2 plus some other constant times t times e to the negative 2t. Those guys, and then you would have some other constant times e to the negative t. Yeah. All right. So this first guy is already in your homogeneous solution, and then this guy, of course, was the same as that guy. These guys are the same thing. My A is my K3. Yeah. Okay. So what does that mean? Your particular solution for 2p is this guy. Yeah. So I'm going to use letters. I'm going to say it's a times t times e to the negative 2t plus a different letter b. I know I called it a up here. Now I'm going to call it b, whatever. Because this was still in my workings anyway. I hadn't committed to a letter yet. should have done was went, oh, this is C3, no, C4, I guess is what I should have called this one, and then now I'm going to call it B. Whatever, loosey-goosey with our letters, but anyway, okay, so we got that, and then I need the first derivative of this guy. All right, so what's the first derivative? Oh, that's chain, or not chain rule, product rule. I'm going to treat AT as my first term, and then I'm multiplying it times e to the 2t. So remember, a is a constant, but t is a variable. That's my independent variable here. Okay, so derivative of a times t would just be a, and then you've got times e to the negative 2t, plus you'll have a times t times the derivative of e to the negative 2t, so that's a negative 2. So this will be a minus 2a t e to the negative 2t. And then the derivative of b times e to the negative t would just be negative b e to the negative t. All right, so now we're going to take these guys and we're going to plug into the d plus 2 operating on x2 is equal to the negative c2 e to the negative t minus 2e to the negative 2t. Yes? Okay. So first derivative of x2 is this guy here. So I'm going to have a times e to the negative 2t minus 2at e to the negative 2t minus b times e to the negative t. And then plus 2 times x2. So plus 2 times, and x2 was this first line. So a t e to the negative 2t plus b times e to the negative t, and then that's equal to negative c2 e to the negative t minus 2 times e to the negative 2t. All right, we're going to equate coefficients. So I've got an e to the negative t and I've got an e to the negative 2t. So how about if I factor out an e to the negative t first, and I've got it here, I got a negative b, and I've got a plus 2b. And then I'm going to factor out the e to the negative 2t, and I would have an a, I would have a minus 2at, and a plus 2at. Nice. All right. All right, so we still have this on the right-hand side. Okay, equating coefficients means that on e to the negative t, that's equal to, this guy is equal to negative c2, and this guy is going to be equal to negative 2. Yeah? All right, well that means negative b plus 2b, that's just b. So b is equal to negative c2, but here, oh, nice, those guys go away. So a is equal to negative 2. All right, so that means our x2 particular is a times t, so a negative 2 times t e to the negative 2t, and then a plus b times e to the negative t, and we just figured out b was negative c2. All right, so now one last step, x2 is going to be the homogeneous part plus the particular part, right? And our homogeneous part was C3, e to the negative 2t, and then plus the particular part, so minus 2t e to the negative 2t minus c2 e to the negative t. And then I'll just rewrite x1 again. x1 was c1 plus, if I was on the page, plus c2 e to the negative t, and then plus e to the negative 2t. And there you go. There's your 2 solutions to to that system. All right, one more. Power through. We can do this. All right. We got d plus 2 operating on x1 plus d squared plus 2d operating on x2 is equal to 5 times e to the negative t. And then I also have d plus 1 operating on x1 minus a d plus 2 operating on x2 is equal to 0. So what I notice is if I tried to get rid of the x1s, you'd have to do d plus 1 on this one and a d plus 2 on this one. But I notice here there's just an extra d on this first equation. So I'm going to operate on equation 2 by a d, and then I'll add it to operate on the second equation by d, and then I'll add it to the first equation. So this would give me a d squared plus d plus the d plus 2. I multiplied the d times the d plus 1, and then I added it to d plus 2. That's operating on x1. When I operate the d on the d plus 2, I'd be having d squared plus 2d, and this guy's positive, and that one's negative, so those guys cancel out. Derivative on 0 is still 0, adding it to 5e to the negative t. So what does that become? That becomes d squared plus 2d plus 2 operating on x1. Yeah, that's going to be my new first equation. That's my new equation 1. And then my second equation is going to I'm going to still keep my second equation. Yeah, why don't I write it just that way? Now I've got my first equation is this one. My second equation is now d plus 2. Okay, so there's my new system. Now, so let's go and solve this first guy, the first equations. Associated, okay, so to solve this guy, we're going to go for the associated homogeneous first, which is, if I were to solve d squared plus 2d plus 2 operating on x1 equals 0. So that does not factor. Two numbers that multiply to 2 and add to 2. So I'm going to change it to an r. It's an r squared plus 2r, leaving a little space, negative 2, leave a little space. I'm going to complete the square. This is a plus 1. So that becomes an r plus 1 quantity squared is equal to negative 1, which means r is equal to negative 1 plus or minus I. So this time you have an a is equal to negative 1, and then b is positive 1. So x1's homogeneous is c1 e to the at, so a negative t, times cosine of b times t, plus c2 e to the at, so negative t, times sine of bt. Yeah. Okay, so there's an associated homogeneous for x1. And now we're going to find the annihilator. The annihilator of 5e to the negative t is just d plus 1, which that just means your r is negative 1. And so the particular for x1 is just c. I better do another. We already used c1 and c2, so don't use those. Use a different one. c3 e to the rt, so negative t. So there's your particular. And so we're going to end up plugging them into, we're going to be plugging it into this equation. No, sorry, this equation up here. Nope, it's not on the screen. I'm going to be plugging it into here. So I need the first and the second derivative of x1's particular. So I've got x1 particular is a times e to the negative t. So that means its first derivative would be negative a times e to the negative t. And then second derivative would be a positive a e to the negative t. And we're going to plug that into the d squared plus 2d plus 2 operating on x1 equals 5 times e to the negative t. All right, so second derivative would be a times e to the negative t. We're going to go 2 times the first derivative, which was a negative a times e to the negative t, and then plus 2 times just x1, so a times e to the negative t. And we're going to set that equal to 5 times e to the negative t. All right. Hopefully you see. Bye-bye. Bye-bye. And so you got a times e to the negative t is equal to 5 times, all right, a is 5. So your particular is 5e to the negative t. And so x1 is going to be the homogeneous, which I've actually got on the screen right now. Nice. So x1 is going to be c1 e to the negative t cosine of t plus c2 e to the negative t times sine of t, and then plus the particular. So plus 5e to the negative t. So that's going to be your x1. Whatever. Yes. Now we got to find x2. To do that, I'm going to substitute this whole thing into x1 on the second equation. So I'm going to substitute into equation 2. And equation 2 said, write it, d plus 1 x1 minus d plus 2 operating on x2 is equal to 0. Okay, so if that's true, then I can add this over to the other side and get, d plus 2 operating on x2 is equal to d plus 1 operating on x1. All right, so I'm trying to solve for x2, so obviously I don't know what to substitute in there, but I can substitute the d plus 1 operating on x1. Yeah. All right, so that this isn't too long, I won't go through all the steps, but keep in mind, I'm taking the derivative of x1 up here, because d of x1, I'm going to take the derivative of this whole thing and then add to it the whole thing. It is product rule, so doing this would be a negative c1 e to the negative t times cosine of t, and then minus a c1 e to the negative t sine of t. And then derivative of this guy would be a negative c2 e to the negative t sine of t plus the derivative of sine, which is cosine, so a plus c2 e to the negative t cosine of t. Derivative of the 5e to the negative t would be a minus, minus 5e to the negative t. That's just the first, that's d operating on x1. And then you'll have a plus x1. So I've got a plus this whole thing. So c1 e to the negative t cosine of t plus c2 e to the negative t sine of t, and then plus a 5e to the negative t. And a whole bunch of things are going to cancel right now. What do I got? Oh, bye-bye. Got ta-ta and bye-bye. Yes, okay. So that, I'll rewrite this again. D plus 2 operating on x2 is negative c1 e to the negative t times sine of t, and plus c2 e to the negative t cosine of t. All right, we're going to solve this, which we can do. Start off with the associated homogeneous, and that would have been solving d plus 2 operating on x2 is equal to 0. Well, that's an r equals negative 2, and so x2 homogeneous is a c, I've already used c1 and c2, so this is going to be a c3 e to the negative 2t. Now, the particular is going to be an a e to the negative t sine of t plus b times e to the negative t cosine of t. And so the first derivative of that guy is, again, product rule. So a negative a e to the negative t sine of t plus a e to the negative t cosine of t. That was just the derivative of this guy. Do the same thing here. Again, it's product rule. That means it's a minus b e to the negative t cosine of t and a minus b e to the negative t sine of t. Yes? And so we've got that d plus 2 operating on x2 is equal to, so the derivative would be this guy. Oh, goodness. Okay, I'm for sure not going to have enough room. Can I combine anything? Not really. Okay, so first derivative, negative a e to the negative t sine of t plus a e to the negative t cosine of t minus b times e to the negative t cosine of t minus b times e to the negative t sine of t. Yeah, that was the first derivative on x2. And then plus 2 times this guy. So plus 2 times a e to the negative t sine of t plus b times e to the negative t cosine of t. Okay, now, and this is equal to, yep, equal to this guy here. So it's equal to a negative c1 e to the negative t sine of t plus c2 e to the negative t cosine of t. Okay, we're going to take this left-hand side and I'm going to equate coefficients. I need e to the negative t with sine, and I need e to the negative t with cosine. So left-hand side, let's start with e to the negative t times sine of t. When I factor that out, I would be left with a negative a, right here, minus b, and a plus 2a. And then I've got a plus, I'm going to factor out e to the negative t times cosine of t, and I would be left with an a minus b plus 2b, and all of that is equal to this right-hand side, the negative c1 e to the negative t, and c2 e to the negative t cosine of t. Okay. Equating coefficients means that this guy must equal negative c1, and this guy must equal c2. All right. Not done. We're almost done. Almost there. We got it. Hang in there. Or pause it for a few minutes and take a break, but I can't take a break. So, okay, so what does that mean? I've got negative a minus b plus 2a means a minus b is equal to c1. Here, I've got a minus b plus 2b, so that's an a plus b equals c2. Well, I should have written them right underneath each other, because if you add these guys together, I'll write it over here. Add them together. Oh, let's bring it over here. Okay, add them together. You got a 2a is equal to c1 plus c2, which means a is equal to 1/2 of c. Where did I mess up? Negative c1, negative c1, negative c1. So how about if I write c2 minus c1? There you go. No? Sorry about that. Missed that negative sign there. Okay, then here, if a plus b is equal to c2, then that means b would equal, do I, that one? No, because I just used it. Okay, no, I'm going to use this first one here. Taking this guy over, I've got b would equal A plus C1, which means I just found this. A was 1/2 C2 minus 1/2 C1, and then plus another C1. So that means B is equal to 1/2 of C2 plus C1. No, my arithmetic's right. I know I'm skipping steps, but whatever. This video is too long as it is. All right, so we got your particular for x2 is, can I get it on the same screen? Slide it down. Okay, here we go. You got a times negative, or a times e to the negative t sine of t. Well, we just found a was this. So I've got 1/2 c2 minus c1 e to the negative t sine of t plus b times e to the negative t cosine of t. But your b is this guy. So a plus 1/2 c2 plus c1 e to the negative t cosine of t. And now we can write x2. Just don't forget the homogeneous part. The homogeneous part was up here, C3 up there. So here we go. X2 is, the homogeneous part was C3 e to the negative 2t. And then the particular part is this whole mess. All right, loss. 1/2 C2 minus C1 e to the negative t sine of t plus 1/2 C2 plus C1 e to the negative t cosine of t. And x1 I already wrote, but I'll just write it here just so that way it's right by each other. C1 e to the negative t cosine of t plus C2 e to the negative t sine of t, and then plus a 5 e to the negative t. There's your solution to that system. Not horrible. Kind of was. I get it. Okay. All right. I hope you're having a fabulous day. Bye.